Here I am today talking about what to look out for when migrating to your data in the cloud. Is it really the right choice? Because don't do it by default. That's my say. A couple of words about me because I'm an old-time speaker by now, so I do seem young, but I'm pretty old-timey too. So I did all the major conferences in the world, so especially GroupBy, which is the #1 online conference in the world. Currently, I'm the manager at EMEA, Acer, the company that makes your laptop probably. And I'm the manager of the Department of Data Science and Intelligence. I've worked with a lot of Microsoft data technology. That's why I'm here. I started with SQL Server, then with Azure, Synapse Analytics, Data Lake, Power BI, and now I'm doing a lot with AI, of course. So that's my thing. You'll find me loving ducks all around. So for this reason, I now live on Lake Como, since we have a lot of ducks here on Lake Como. But if you want to learn more about me and stay connected, please add me on LinkedIn. My profile is open. You can talk to me there, whatever, ask question anytime. Absolutely no problem. But let's get right into what we're going to say today. What is the cloud? If we find on the right definition that Mark Bainhoff, the founder of Salesforce, says is if someone asks me somewhat what cloud computing is, I try not to get bogged down with definitions. I tell them, simply put, cloud computing is a better way to run your business. That's the Mark voice. And you're like this, you're like, wow, shock. Cloud is so amazing. I can do whatever I want. I save money. Everything is faster. Everything is cheaper. It's super powerful. Wait a minute. Why are we doing all of this? Because in my adventure at Acer, we did exactly this. We did a full migration from mostly on-premise systems to full 100% cloud system. So remember, just a small disclaimer before we start. This is a session to help you evaluate if the cloud is a good choice for the company. But as everything in IT, it depends. There are no definitive answers. Anything could be good, could be bad, could be a great success or a terrible waste of resources. What I'm here for is to help you navigate through the various questions that you might have, the various issues that could arise, and help you think about evaluating if the cloud is the right thing for your specific business case. I hope everything is trivial to you, because if it's trivial, this session for you, it means that you are on the right track in understanding what the cloud is. If it's not trivial, pay attention, because it needs to be as soon as this session is ended. But first, bear with me for a second, because we need a refresher on a couple of non-technical aspects. So why your business wants to move to the cloud in the first place. So recap very, very fast. CapEx versus Opex, capital expenditure versus operational. Capital are the type of expenses that you need to ask permission to somebody higher up to approve. So big funds that are major physical goods like servers, for example, in your case, that needs to be approved through several layers of management. So you will need to do the request, it needs to be approved, and this B2B recorded on the balance sheet, and the expenses on the capital can only reduce the taxes through depreciation, while operational expenses are like the day-to-day. So they are your subscriptions, your electricity, your whatever, and those are fully tax deductible in the year they are made. So this is why the business wants to move to the cloud. So there is no technical reason, there is financial reason to move the expenditures from depreciation to operational, so they can be deducted, not with the depreciation of the goods, but with the actual expenditure of your cloud bill. Now you know why the business does it. Types of cloud services. Again, super easy recap. You should already know that we have the infrastructure service, IaaS. So here you're simply getting rid of physical hardware and moving this hardware on the cloud. You access your hardware that you would have in your own data center on the cloud data center. Then you have the platform as a service, where you get rid of all the part which is installation and updates. So you don't care about upgrading the software, you don't care about the security patches or whatever, because you simply use the platform as it is. And then the final boss is this software as a service, where you get rid of anything except the software that you're using itself. Some example could be infrastructure as a service, a simple VM, a virtual machine that you have deployed on the cloud that you access. Platform as a service, maybe Azure SQL or a SQL managed instance, where you simply access SQL, but you don't have to care about installation, upgrade, etc. And then SaaS is something like, I don't know, Dynamics 365 or even other tools like this, where you don't care about infrastructure, you don't care about the configuration, you don't care about the architecture, you just use the software. That's it. So you've seen here that you are getting rid, and you should be scared to say, oh my God, are they going to get rid of me too? We'll see. Maybe not, maybe yes, depend on how good you are. For new companies and the cloud, it's usually a no-brainer. So this is a session for mostly existing companies, because if you are a new company that doesn't have a lot of capital, it's easier to start up with the cloud, because you don't have upfront investment. You have lower capital risk, because if things go bad, you simply shut down everything. It's the faster creation of MVP, because if you need some VMs, you click a button, you have a VM. You don't need to order from the distributor and then find a data center, plug it in, configure it, install. It takes a little bit less time. So, and even if you want to pivot your business, which happens often during the early stages of startups, then it's easier. You just shut down, recreate, redo, instead of having some hardware physically in your premise that you're like, what am I going to do with this? I have no idea. So that's the thing. And of course, as a business model, a SaaS product is easier to try and adopt, because you have the profit, which is right away the EBITDA, because you have literally your expenses are there. What I get as a revenue is this, one minus the other, and I have my money. It's way easier than calculate the depreciation of the capital and then project into the future. So what we are most interested in, however, is the existing company in the cloud, because here you have a lot of choices. Here you have your existing application, your existing infrastructure, and you have to ask yourself a lot of questions. For example, you have to ask for sure, what is your goal? So why are you doing this? Are you doing this for cost savings? Are you doing this to create a new product? Are you doing it to create faster performance? You need to evaluate, because each of these is not natural when you go to the cloud. It's not automatic, but there are a lot of consideration. Then you have to ask yourself, what does your current infrastructure look like? Are you migrating because the hardware is end of life? Are you migrating maybe because it's just slow? Do you think that migrating to the cloud, it will magically be faster? I don't know. This is really not the case often. And then think about also your team, and think about what technology does your team knows deeply. Because are you willing to invest in their formation and or get new hires? It's not automatic, because the handling of cloud is slightly different than the handling of on-prem, and different consideration needs to be made. But thankfully, we're here exactly for this. Here I have some numbers now about the state of the cloud. I should update it with the new report, which I think it came out recently. So, but the numbers are always similar. And what I want to say is the overall trend of the cloud migration, where the majority of enterprises always, every single year, indicates that managing the cloud spending is a challenge, because they go in without thinking, without following this session, and then they have issues about, oh no, I'm spending too much, I'm not able to control the cost, everything is going out, it's a mess. So everybody is complaining about the cloud spending. Everybody is trying to get cost efficiency measures in order to bring it under control. Everybody almost is trying to optimize the existing use of the cloud and putting it as a top initiative. But at the same time, you can see that most of the enterprise workload are or are going to be in the public cloud in the next year or so. So there are two things, which is people are still migrating to cloud, but still people are not able to control the cloud spending. And as a last number here in the slide, you have that a lot of organizations are estimate spending almost 20 to 30% overspend rather than the budget that they had for the cloud. Why? Because they didn't consider all the items that we're going to consider today in this session. One other consideration that we have to make is everybody should be on the same cloud, so everything you deploy on the same cloud, or you should be using multiple cloud vendors. Again, this is a choice. There is no single answer. In our case, for Acer, we have multiple cloud, but for business reasons, not only technological reasons. There is a lot to be considered about the business, about the talent in your company, about what one cloud vendor can offer versus the other. So remember, you've also find the article I wrote about this in the past in my blog. But basically, as you can see, if you have everything in the same cloud, possibly you will have a lower total cost of ownership because maybe you can find more bundles, more discounts if you spend more, and then you have less, at least, egress fees, where egress we will analyze in a little bit what does it mean. And you have to move data around a little bit less, hopefully, because you don't have to move it from one cloud to the other. You can reduce the ETL complexity, etc., and you can hire specialized people on it. But maybe the issue is maybe you are locked in. Maybe you get a suboptimal feature set. Maybe the database that you have in another cloud is better. Maybe it's cheaper somewhere else. Maybe they have some feature that you don't have in the current one. So again, difficult to decide. What about multiple cloud vendors? Maybe you have a lower risk, but maybe it's the risk of differentiation. So for sure, each and every single cloud vendor has a low possibility of failing, but who knows? You can move around. For sure, you have a high flexibility, and then you have, of course, the best of breeds solution, where, of course, you can pick and choose whatever. But probably you will have higher cost because you have to move the data around. You need to have more knowledge. You have people to be trained on different cloud. You have maybe security and governance issues, also visibility, because stuff is all over the place. It's not centralized, but is in different clouds. Also, maybe comparing the monitoring and logging of different resources in the cloud could be an issue if you're not using the same tool all over the place. Having said so, 92% of enterprises have a multi-cloud strategy, so it explains why most of them are everywhere. Then, since we love big numbers, I have another big numbers here, which is the number of updates per quarter that I see in Azure. And here I just counted an average of how many updates do you get on the Azure updates blog. Is more than 50 per quarter. Maybe we haven't sped up even more recently. And you'll be like, oh my God, all these changes are difficult to follow, because we know the feeling. Everything is going forward so fast. It's difficult to stay ahead. But on the same page is most of the changes, not all of them, because maybe you get new feature, maybe you get different tools, deprecation of tools, but most of them don't require any action because the cloud vendor is innovating for you. But again, the change here is fast, and you have to keep it up. So what have we learned up until now? That the cloud is not supposed to be cheaper. So it's a cheat code around bare metal. If you take one service that you do it yourself on bare metal under your desk and something the same in the cloud, the long term, the bare metal should be cheaper, because the cloud, the first element of the cloud, is not designed to be cheaper. It can be cheaper. For economies of scale, maybe something can definitely be cheaper than bare metal, but it's not supposed to. It can, is not always, is not supposed to. It's mostly a wrapper for your convenience, because rather than having a VM in my closet and then having to maintain it, redundancy whatsoever, it's in the cloud. I click a button, is there. You're just exploiting somebody else's economy of scale. So when the economy of scale works in your favor, this is good, but keep in mind that the cloud vendors are making money too. So it's not like you are freeloading up on them, but they are definitely get some kind of revenue out of you. So it's not magic cheaper for everybody. The thing that you have to focus is the ability of being flexible and with fast deployment, because what you need to have in the cloud is exactly this. So a cheat code not supposed to be cheaper, can be cheaper if you scale it properly. Very convenient because it's flexible and fast to deploy by the exploitation of somebody else economies of scale. So remember what is the cloud from this. Finally, we can go a little bit deeper on the topic for your technical people here. We can go ahead. Problem number one, the data lake trap. So I call this the continuous upselling. In my career and in reading all over the internet for blog, inference, etc., I always say this: countless companies burning large amount of cash in search for the big data solution, just because the management was driven by the hype. And the same is going on now with AI. So same thing, change big data with AI, same thing. The numbers are the same because 60 to 85% of this project fail, simply fail, because what's going to happen? The vendor is telling you, look, you need all of these services, which is cutting edge. You can just throw everything down and everything will be solved for your business. Not so fast, not so fast, because you have to choose what is the right solution for you. Ask yourself, what is the problem that I'm trying to solve with this? Because I guarantee you, you go to a vendor, you ask for an architecture, and they come up with 10 different services all put together. Because yes, you need streaming interface, and then you need event-driven database with big scale and NoSQL. No, don't fall for it. Because you have to choose the right technology for you. They are completely filling you with buzzwords. Everything is real time, time scale, petabyte, streaming rich data. You have to ask yourself, what do I need now? What is the problem that I'm trying to solve? And which are the business requirements behind all of this? Because this is the base. These images right here are like the base infrastructure that they are suggesting you for any data loss. And you're like, why do I need this much? What am I trying to solve? Maybe I need this, maybe I need more, but don't sign off on come on, everything as of this. Because remember, one of the key features of the cloud is flexibility and being fast. So I can deploy 1/10 of that, and then if I need to deploy the rest, it takes 10 minutes. It's not like on-prem, where you need to decide today the architecture that you will use in the next 5 years for it to be useful in depreciation. Remember, flexibility. So you can do with one thing now, and the day after tomorrow you can do, okay, let's deploy the rest, because now we have decided that we can. So use the flexibility of the cloud. Don't think about the cloud like you always scheduled the updates of infrastructure of on-prem. Otherwise, you're not using the cloud. It doesn't make any sense to use it like this. It doesn't make sense to set up the cloud infrastructure for the next 5 years. Why? Tomorrow it could change. So leave up some doors to be still open. Also, probably your apps needs to change. Yes, they need to change, because the main point of all of this is there is no real cloud transformation without a change in your ways. So you have to forget the classic phrase, it always has been done like this. No, because if you want to do what you always did, then you always get the result that you always had. If you want something new, you have to think about it differently, and you have to change your way and adapt it in order to exploit the cloud features in a decent way. Otherwise, everything is lost. Let's go to the first hurdle that we have. So the lifting and shifting. Lift and shift, pretty easy concept, is I get what I have on-prem and I shift it to the same architecture on the cloud. Usually is I have virtual machine on-prem, I take this virtual machine, these applications, and I put it in virtual machine in cloud. Easy peasy, but think about what you're doing. Could be a good choice, could be not. Because lift and shift is a classic business move to get to the cloud fast. How many times they say, oh yes, we got to the cloud, and then you have exactly the same architecture that you had on premise in cloud. That's it, nothing else. But it can be a good solution, especially if it's a short-term solution, or long-term, if you have non-business critical system or legacy system that doesn't make any sense to modernate, to make it more modern, then you can just lift and shift it. Who cares? If it's not expensive and you don't spend any effort, leave it there. You don't care. It's good. It can be a good move for hardware which is end of life, because if you're going to spend for new hardware, regardless with a capital expenditure, you can transform this expenditure in an operational one and get fast in the cloud like this, moving since you were going to move anyways, and get new hardware straight from a cloud vendor, and maybe you can then upgrade this hardware easier in the future. The infrastructure, of course, are higher. The infrastructure costs are higher than continue to use your servers, because if you have your own data center, your own servers and everything, you already own them. The cost is spent. So if you're going to the cloud, you're going to start from scratch, spending in somebody else's server and somebody else's network. So if you have everything already there, do the proper calculation about how much are you spending in electricity, how much are you spending in cooling, how much are you spending in general maintenance of this data center and these servers. Because if you already own everything, if you're going to cloud, then you're starting from zero. You don't have your baseline, your capital expenditure is lost. That maybe is that's your goal, maybe not. So also what I just said is you need to be able to scale up and down, because in the cloud you can own the servers rightly sized for you. But we will talk about this in a little bit. One other thing that you have to mind is, please mind the network and expect latency. How come? Especially if you lift and shift parts of your application in the cloud, latency can literally bite you. Because not necessarily because the cloud is bad. No, absolutely not. They have the best infrastructure. They have the best network in the world. They have the best internet, of course, number one. But maybe you're used to the sub-millisecond latency of the server that's in your closet right there. And having a server which is not in your closet, but in another country, maybe that's too much for your application, because maybe your application is super chatty and expected super fast responses. And by simply being limited by the speed of the light, the physical speed of the light, maybe that's not enough. So be careful when you migrate to the cloud. Verify the level of chattiness and how latency affects your app, because it could be, probably not, but could be an issue for you. Another thing that can be an issue for you are the egress fees, because now you're in your data center, you take the data from one rack, you send it to the other, everything is free. You literally pay only for the electrons used to move this information from one place to the other. But cloud vendors are clever. While importing the data is mostly free every time, getting it out is a little bit more difficult and always costs you money. Here I have some sample pricing. So the pricing is not that high, of course, because I mean, we're talking about network. But if you are moving a lot of data outside your cloud, or even between the same cloud itself, so if you're moving data from one cloud region to another of the same cloud vendor, so if you're moving from, I don't know, US Central to West Europe or vice versa, that's always incurring in an expense. The price you pay when you're getting data out of a cloud data center is called egress, which is the opposite of ingress, which is when you get data in. While ingress is mostly free, I don't even remember when it's not free. Egress is mostly paid for. So whenever you have lots of data in the hundreds of terabytes to petabytes of data of traffic, be very careful. Otherwise, you will do like NASA. I think that they had to do some egress of some data, some petabytes of data, and it cost them $12 million because they had to pay the egress fees, and nobody had thought about that when they were thinking about these cloud migration. So be careful, absolutely. Then I have a little trivia for you that is what happens if somebody tried to do a denial of service attack on your server? Of course, you get the bill. Like it happened to this lucky guy where using an online services that he put up, he was attacked basically by a third party for unknown reason. And then since he had basically a service that downloaded data externally, he got hit with a 60 terabyte bandwidth attack of DDoS, and he had to pay the bill. Then, of course, there was discussions with the cloud vendor, etc. Because come on, you didn't protect me for DDoS, and then I have to pay. But could happen. The same thing could happen if you are amazingly successful with your cloud application and you have to get a lot of data to a lot of customer. Remember, you're going to pay for data that is coming out of your cloud. But some good news, because post DCA, which is the new regulation here in Europe, now it's easier to transfer data out when leaving a service. So everybody is aligned. So Azure, AWS, Google, everybody is now complying with this. So if you are going to migrate your data off, definitively from your cloud, then you're not going to pay for the egress fees. So poor NASA that had to pay 12 millions. If that operation was done today, they wouldn't have paid because they were going to migrate. So it's easier in order to avoid the vendor lock-in, because you can imagine up until before the DCA, you would have all of your data in one cloud, and then you say, oh, let's migrate to another one, and you couldn't because it was so expensive to get all of your data out that you would pay for egress fees. But now, getting off at all completely from a cloud is free. So your egress is completely free. Thankfully, one regulation that makes sense, except all the others that are basically crippling our economy. But another thing that can help you is using Cloudflare R2, because as opposed to Azure storage accounts and Amazon S3 and whatever, Cloudflare R2 doesn't ask you to pay for egress. So if you are interested in egressing a lot of data to a lot of customers, take notice, Google Cloudflare R2, and it should be pretty simple to set up and use this as your object storage instead of S3, where you pay way less egress fees. Then what you need to do, you have to know, you have to control where your data is, because we talked about the location of the data and everything else. But remember that, as always, is not a perfect game. And you cannot win 100% this game. There is always compromises, because it's all of a game of balancing. So you have to balance the region exclusivity. So let me get back to the previous slide to highlight what I'm saying. So in theory, you have to balance the following items. Region exclusivity. So if you keep all the traffic within the same region, and I hope that the concept of a cloud region is clear, but basically the cloud region, as you can see here, is one or more data centers that are comprised in one region. If you keep all the traffic between the same region, you don't pay for this kind of egress fees between different regions, and so it's cheaper. So if you keep it close, it's good. But of course, maybe you need the data to be closer to your customers, so maybe you cannot do it. Another thing you should do is keep the region proximity, because the closer your cloud region is to your premise or to your users, the lower the latency. So if you are in Switzerland, maybe you want to use Switzerland Nord as a data center, as a region. But maybe your company is based, the headquarters is based on in the US, and you want to have US one. So where you're going to put your cloud resources, Switzerland or US? You have to think about. Also, you have to balance the same thing. You have to balance the availability zone. So availability zone, again, are one or more data centers in the same region which talk to each other. If everything is in your availability zone, usually you don't pay any kind of networking fees for the traffic inside of it. But if you communicate with other availability zone, then yes. But if you're in just one availability zone, you may understand from the name that the availability zones are built exactly in order to make your applications more available, more resilient, because one goes down, the other one comes up. So maybe you want data residing in copies in different availability zones. So you increase the availability of your data, but at the same time, you increase the cost. And another thing is geo-replication, because when you have critical data that you have to fit a very tight SLA, maybe you want it replicated in another region of the world. But again, this is going to cost you money, and you're going to send data outside, so you're going to pay for the egress. So again, it's not easy, because there is no perfect answer, but there is all of this game of balancing where your region needs to be, close to me, farther to me. Do I need one region, or do I need multiple regions? Because maybe I have an enterprise which spans multiple countries. And in the same region, do I want just one availability zone to be used, or multiple? Does my application, which kind of SLA my application needs to satisfy? Am I fine if one availability zone goes down to stay down and not have any kind of other type of resources in another one to continue my work? That depends on your business, depends on your agreements with the business, your RPO, your RTO, all of this, which you need to balance. So there is no exact choice. It's only you have to balance. You have to balance everything, all of this. I want to finish this egress part with a bonus tip. So when you have time, you can search for this article by Daniel Kleinstein, which shows you some tactics in order for saving a little bit of money when doing transfers of data in AWS. But this can be applied to other clouds. Is the method to be applied, and explains very well what's going on with all this kind of egress fees and data and whatsoever. So you can do a read about this. It's pretty interesting. Then, as we said, cloud. One of the powers of the cloud is scaling of these services, which, as you might have understood up until now, is not that trivial. So depending on the service, scaling up and down can serve you a lot, because it can have you save money. It can have you optimize your load, scale for with your business, etc. But you have to understand how these services scale. Can they scale up, down? Can you turn them off completely? So if you're using a cloud VM, like an on-premise one, so if it's always exactly the same, it is never changing, and it's all, why are you going to move it? So if your VM on-prem is paid for, and it's always the same size, and the size is perfectly scaled, and it's going to work perfectly for the years to come, why are you even considering migrating it to cloud? maybe it could make sense for your bigger picture of infrastructure. Maybe not, because that's not the point. You have to make a lot of consideration when scaling, because it's way different than on-premise. Because on-premise, remember, you already paid for everything, and here you are paying for what you use. Then you need to ask yourself, how can these services scale? Can it be turned off completely? And then how long does taking scale? Because remember, some services can scale in seconds, some services scale in hours. And trust me, I know, because I use SQL Managed Instance. SQL Managed Instance, in order to scale from one SKU to the other, it needs to back up every database, create a new instance, meanwhile restore the databases on the other hidden instance, align the transaction log with the new one, and finally cut off. It takes a while. It doesn't scale in minutes. Then you have to ask yourself, does your application support horizontal data scaling, or it needs to be backed on the data layer? So you need something transparent with one endpoint, and then everything is taken care of by the cloud vendor, or you can have something which automatically handles horizontal scaling. And then maybe ask yourself, does this dev instance really need to stay on 24/7? I don't know about your developers, but I surely don't work 24/7. So ask yourself also that. Other considerations on scaling that we have is that depending on the service, scaling up or down may not be seamless. Again, usually you get a drop of connections, and this drop of connectivity, is it something that you can tolerate? Usually, remember, when you have a cloud applications, is way different than on-prem, because you always have to account for network unavailability, and you always have to implement retry logic, because you can have the most available cloud services ever, but always there is sometimes that the connection fails, and sometimes you have to just try again, and then it works. Why? Mysteries of the network. But when you're going to cloud, not having a retry logic for any application is a very bad mistake. It can get you back. Then think about also the service scales down automatically, scales up and down automatically depending on the load. For example, like container apps that you can set a number of containers and then dynamically they go up and down, or you have to programmatically scale it yourself. So maybe a schedule based on the time of the day, based on your business times. Who knows? Think about it, because again, not everything is automatic. If it's not, you have to understand yourself how it works, etc. Then finally, as we said, while vertical scaling can be almost transparent, except the downtime, because we said even if I upscale a SQL instance, eventually the connection needs to be dropped, even for a millisecond, but they need to be dropped. The horizontal scaling, no. How does it work with your app? So think about it. And then finally, if your data is getting spread about across multiple locations, you really have to think how to distribute it. But this could be another session. One thing that I like in my life is performance and optimization. And here in the cloud is even more important, because when you are in the cloud, the performance is literally money. Because think about it, it's very simple. Scaling up usually happens for two reasons. Good reason is there is an increased request of volume to your system. So usually it means the business is doing great. You have a lot of data, a lot of requests, a lot of application, everything is going perfectly. Or most probably, unfortunately, a bad reason, which is there is a performance problem that you can just fix it by throwing hardware at it. So on-prem, this happened less frequently, because if it happens usually at the beginning, you have your system which is scaled in such a way to be ready for the next 3 to 5 years. So a small performance issue at the beginning, you don't realize it. But then, from your experience, I'm pretty sure that you have realized that while the system goes forward, everybody say, oh no, the performance is going bad, because your bad code at the beginning of the history of this service was hidden by the oversize of the on-prem solution, because the on-prem solution hardware is ready for the workload expected in the future. So at the beginning, everything is fine. Then a couple of years pass and you find yourself with a bad system because you didn't fix the performance issue. And then everybody's screaming, oh my God, what are we going to do? And finally, someone came and fixed it. In the cloud, it's even worse, because you save money in the cloud only when you perfectly size your service around your workload. And since the cloud is so fast and agile in scaling, you right size it, and then where the system needs to scale up for a good reason, you size next step up, and everything is optimized. If you simply throw hardware at it by increasing the number of the size of your machine, on the size of your resource, you are doing an expensive mistake, because probably you will forget that you did it, and you will spend a lot of money until the next performance issue. So really, even more importantly, in the cloud, you should be optimizing your queries and your system and your applications very well, because the most optimized they are, the smaller size of a machine you need, and the cheaper it is. So it's a win-win-win by optimizing. So this needs to be you, because when your developer comes to you asking for more memory, you have to say, your query sucks. Even if you say, I need more CPUs, you need to tell them, fix your query, damn it. Because by fixing your query, you're not spending more money. And they will always try to tell you, I don't want to fix it, I want more memory and CPUs because this is a bottleneck of the system. Fix your queries, please. So the job of the DBA, it's even more aggressive here. Fix the queries, because otherwise we are literally going to spend more money, and you will see it immediately in the operational expenses. So do this to your developer. Developers, you suck, fix your query, or fixing it for themselves, because come on, you're literally showing that wasting money for the company. So you get more power. Speaking of performance, please mind the IOPS and throughput limit. It's a difficult time. So when selecting a PaaS database, so a platform as a service database like Azure SQL, like a SQL Managed Instance, if we're talking of the Microsoft world, the IOPS can become a very limiting factor if not considered, unfortunately, especially on the Microsoft SQL Server-based products. Go into the documentation, look at it, look at the product, because it needs to be taken in consideration. Because, for example, these are the limits of the SQL Managed Instance files. So the data file, the log file, the various throughput. You can imagine that these are not big numbers. But now something has changed. You can scale the IOPS separately with the new system for SQL MI. But in general, the numbers are not so good. So even if now they're better, in general, they're not so good. So if you have a system on premise which has 10 NVMe SSDs with a lot of throughput in write zero, because you just need the IOPS, consider and do a lot of testing in cloud, because usually the IOPS are way more limited. So for a system that may have a lot of CPU usage and everything is in memory and everything is cool, transactionally fantastic, little bit of difference. System that you need to dump a lot of data, read and write, and the transaction log, it goes fast, little bit more critical. So for fast writing transaction log queries, try. It's easy to try, because you click a button, the instance is up, you try, you shut it down, you spend like $10 and you figure it out what is going on. Another feature of the cloud, very good. So again, numbers that I'm going to show you. So there is a next gen version of the general purpose tier for SQL managed instance in this case, that they actually increased the number of IOPS better. So they lower the latency, they increased the total IOPS, they increase the total throughput of the log. But if you have super powerful storage layer in your on-prem, that can still be faster. So test it out, test it out. What do we have now? One more thing about saving money, because I'm a big advocate of saving money. I have a little bit of reservation of reservations, because I need to tell you what they actually are. Reservations are super cool, because if you have some kind of workload that you know it's going to be going in that speed with that size for a while, for 1 or more years, then if you put a reservation on it, you save a lot of money, even up to 60% of the total cost. So the goal is to save money, but remember, do a reservation only if the resource must stay online for a percentage of time which is greater than the discount that has been applied. Because if you have a VM, for example, that is test, and you don't need to be on for half of the day, 50% of the time this VM can stay off. Why the hell would you do a reservation for 1 year and save 40%? Just shut it off. Does it make sense to reserve it? Because the reservation, again, is a reservation on the price. Little bit in a while. What you need to do is measure your current workload, analyze it, say, okay, this machine needs to stay online for X amount of time with this size. And if this number says, oh, it needs to stay 24/7, or it needs to stay 80% or whatever of this size because I need it, then perfect. Do a reservation, you save a lot of money. For example, I do this with my Power BI gateway machines. So I have a bunch of machines that need to stay online 24/7 because the users are all around the world. The size is pretty much that one. If I need more, I can do horizontal scaling, so I can push more machines up. I reserve it because then I save a lot of money. They cannot be offline. They need to stay online always, and that's it. So make sure you're buying the appropriate resource for the whole reservation period, because paying more, it's always possible. So they can do an upscale for sure. Why not? Paying less, often not, because they say, oh no, I chose a SKU that was too big. Can you please downgrade me and give me back my money? It's too late. So don't do it. Then finally, remember that you are reserving the price, not the hardware. So you are paying for a 3-year reservation. You're not taking a single host and say, oh, this is my server. Absolutely not. You're reserving the price. Your instance can be moved all over the data center, all over the availability zone as they please. You're not reserving hardware, you're reserving just the price. You're reserving the right of paying this service with a discount defined by the reservation. So don't confuse reserve the hardware with reserve the price, which is the case of reservations themselves. Since we work with data, of course, we need to think about storage and the tiering and cleaning of it. So in the cloud, everybody says storage is cheap, but don't follow the vendors that try to have you save everything all of the time into the cloud, because eventually you will get a lot of data into the cloud and eventually it will be too much and too expensive. Remember that in the cloud there is a tiering option of storage, which most of the time is at least 3 different storages types. One is hot, where you should store only the data accessed frequently or that needs a faster retrieval. So here you pay more for the cost of the storage itself and less for the IO operation. So you're paying more per gigabyte, but you're paying less per access because this data is supposed to be accessed more frequently and it gets accessed faster. Then one step down is why you don't have to have this data accessed so frequently or with such a fast performance. It can be stored in a place where it takes a little bit more time to fetch your data, which is the cool or cold layer. Again, Google this because there is a lot to say the difference between cool and cold and whatever, the pricing, the pages. It's a lot to research. I'm sorry, you have a lot of questions. You will have way more questions today than answer. I'm sorry for it, but that's my job, creating questions. And lastly, then you have the archive layer, which is the cloud equivalent of tapes. You might have to wait 4 hours to get the data, but it's cheap. So the cost per gigabytes or per terabyte is pretty low, but when you need to access it is expensive. So of course, archive data is like the old backups or the old auditing logs that maybe you will never access it in 10 years, but maybe one time you will need to. And so that's why you use it. Finally, remember, maybe does all your data needs to be archived as it is, or maybe you can aggregate it to save money. Again, depends on your data, depends on the user case, depends on the law of your country. But think about it. Don't just throw everything. Just 10 minutes. Think about the data. Please, somebody thinks about the data. Thinking about the data again. Remember, the cloud is amazing. You can create resources very easily, very fast, very convenient, also very easy to forget. For this very reason, and for the, I'm sure it's completely random. It is not related. That is difficult often to check for what's available in your cloud, what has been deployed. Absolutely, I'm sure it's completely. It's a case. It's just chance. You should review your cloud spending every month or at least once a quarter. I know you're not paying for your own pocket, but come on. Keep an eye on your resource inventory because you never know who has the power to create, because I'm sure your security and governance are not like that good. So probably someone has created an instance of something and then forgot and then thought it was a game, but really it's not a game and you're paying a lot of money. So do an inventory once in a while to check what's used and what's not, because it's pretty easy. Your data center, you cannot just walk in with a new server and just put it in. It's more difficult than in cloud. In cloud, you click a button, you create a cluster of 100 machines. So keep an eye on it and try to use the vendor tools for budgeting and cost allocation to identify what the hell is going on. And maybe check also the invoices, because it's so difficult to do invoicing that maybe sometimes they get it wrong, and this may or may not have happened to me. So just an advice. Final trivia for you today, which is which are the things you can say to your cloud vendor but not to your partner in bed? So from all the session that I've shown you today, now it should be clear what the answer should be. I want it to be fast and cheap. So you cannot say this, especially to your vendor. Finally, we are almost at the end and perfectly on time. What will be the role of the cloud DBA? It will be a change in the task, a change of responsibility also. Because the cloud DBA, at least the classical concept of DBA, because DBA is such a wide concept nowadays, usually did the troubleshoot of the outages, the patching of the services, the backups. I didn't write testing restores because nobody does it, even if they should. So, but you should do test of the restores, installing, configuring the system, optimizing the query, whatever. This is the old ways. In the cloud DBA, it's a slightly different figure because you need to be aware of the platform architecture, because depending on the architecture, the cost, the performance, and everything else changes. And by changing this and changing the scale, of course, you enter the realm of cost management, because the more the bigger the size, the bigger the cost, the more you can do performance optimization, which is one of your other big tasks, the more money can be saved. So you have a more direct impact on the books of the company itself, because you can literally say, look, I've optimized all of these queries in this server, and now we switch down from 2 sizes in the cloud, and we're saving thousands of dollars every month. You're welcome. Please give me a percentage. That should be you. So you can configure the scaling by managing closely the architectural part of this system. So it's a slightly different job. So you still need to know the same things, but a little bit more on the infrastructure itself. Then I want to give you some key takeaways of all of this. Number one, be aware that the vendors are trying to lock you in. It's business. It's not like they're evil. It's just business. We also, as a company, want you to use all of our products as much as possible. But in the cloud, there is a lot of things that can actually be done to lock you in. But it's technology in general. So be aware, not because they are evil, that's because just it's the business that they are in. Try to get to use more and more and more of their services. For this reason, try to use the most portable tech available if possible. So maybe if you use something like, our beloved Microsoft Fabric nowadays, they luckily have allowed us to use Delta Parquet format for storage of data. That, of course, can be taken out and bring in any other cloud. Do something similar for any tech if possible. So you don't want to be in the position that you are not able to migrate. So maybe don't go to Oracle Cloud. Then please set up budget and spending ceilings just in case. You never know. The internet is full of horror stories about AWS making you poor. So remember to do that. Also, always do your math, because the cloud can either be amazing or it can be a very, very terrible idea. In order to keep up, what you can do, learning is a very difficult part, but if you're here, you're 50% of the step in the right direction, because you just need to stay up to speed, because it changes so fast that maybe you get a new technology today that will change your life, it will change your business. Unfortunately, big books are a little bit difficult to follow right now. So I recommend stuff like this amazing conference, blogs, also vendor blogs and documentations, and maybe some kind of events. But especially in the cloud, it's very, very easy to just set up your own small instance and start messing up with it. Start testing, start verifying, and doing all these kind of things. If you want some Azure specific tips in the last 30 seconds that we have here together, I can tell you that Azure gives you dev test pricing for, well, your dev test resources. You just sign off a setting, and you basically don't pay for license, you just pay for compute, which is very, very useful. If you use VM, take notice of the B-type burstable VMs. Be sure to delete everything, please. When you're deleting something, delete everything that's been attached to it. So storage, networking, everything else, please keep it close. And then remember that Microsoft is supposed to price match any other cloud vendor for the same service every 3 months. So if you see some other service offering something way cheaper than Microsoft, you can try and ring them up and say, hey, where is my discount? And you can try having it. Closing up in the last second of the presentation, I can just say the cloud is inevitable. So we cannot escape it. We cannot run. We can just do all the consideration, all the inevitable consideration that we made up until now, and use it for the best. Remember, the cloud is inevitable, but you have the power to control it. And that's only on you. And with this, we finish this session, guys. Thank you very much for attending.